Welcome to aminacademy.com. In physics, let us discuss about reflection of light in mirrors, derivation of mirror equation. First, what is mirror equation? The mirror equation is a formula that links focal length, object distance, and image distance. It also goes by the name mirror formula. It's used to figure out the focal length, picture distance, object distance, magnification, and any other necessary information. The object distance is the separation between the object and the mirror's reflecting surface. The symbol U represents it, that is object distance is U. The mirror equation of convex and concave mirror is given by 1 by V plus 1 by U equal 1 by F, where U is the object distance, V is the image distance, F is the focal length given by 2R. Is the radius of the curvature of the spherical mirror, where R is the radius of the spherical mirror. Here, focus is R by 2. Now, we'll derive the mirror equation for we consider the concave mirror. Look at here, this a concave mirror ray diagram is given. By examining the ray diagram, we can observe the triangle ABC. Look at here. Here, first of all, explain the ray diagram. This is a object AB. Then the ray go parallel to the axis and surface and reflect back through F. It comes back like. And one more ray passing through the center of curvature, that is C, that is 2F here, curvature, and come back to original position. And one more ray from A start to the center of the lens, the center of lens P, and come towards like here. Then this is a object AB, A dash B dash is a image. Now, by examining the ray diagram, we can observe the triangle ABC and A dash B dash. Here, the triangle ABC, this triangle ABC. Suppose this triangle, and A dash B dash C dash, and this small triangle A dash B dash C dash are similar triangle. Therefore, the ratios of their corresponding sides are equal. That is AB over A dash B dash equal CB over CB dash. That is the height AB divided by A dash B dash equal BC over B dash C. Similarly, the triangle ABP. The triangle ABP, this triangle ABP and A dash B dash P. A dash B dash P. These two triangles are similar. Look at one more time. The triangle ABP, ABP and triangle A dash B dash P. These two triangles are similar, and that similar leading the relationship. From this relationship, we can say AB by A dash B dash equal PB by PB dash. Here, because of these two triangles are similar, in that we can write these ratios. Combining these two relations, that means first relation is AB by A dash B dash equal CB by C dash CB dash, and this relation we can get AB over A dash B dash this, and CB over CB dash, and this PB over PP days. That is this relation and this relation combining together, we got these relations. Next, measuring the distance from the pole, that is point P, we have CB. Look at here, this CB can be written as PB minus PC. Look at here, CB, this distance is equal PB minus CP. Yeah. Like similarly, CB days. CB days can be written as CP minus PP days. PB days. Look, these two relations. From this relation, substituting the value of CB days. Look at CB and CB days into these relations. We are having, look at here, PB minus PC for CB divided by PC minus PB days for this CB days, which is equal PB over PP days. PB days. Applying Cartesian sign convention, we assign the following. Look at here, this PB is image distance. We are keeping this minus V. By Cartesian sign convention, PB equal to minus U. PB, this is because AB is object distance from the center point P is equal to U. That is, we are keeping minus U. PC, look at here, PC equal, C is the center of the spherical. Therefore, PC equal to radius of the sphere. That is, PC equal to minus R, PB days. PB days equal to image distance from the point P from the center of the lens. That is, it's equal minus U. These are the sign convention. This sign convention, we are applying this relation. That is, look at here, replacing PB days and PC in equation, we have minus U, PB equal to minus U, minus of minus R, and PC is minus R, PB days equal to minus of minus V, then which is equal, PB equal to minus U, PB days equal to minus V. Here, from this relation, we derive something. Simplifying further, we obtain minus U minus of minus plus, that is plus R. Divide minus R minus of minus plus V, and minus plus. This, look at this relation. Now, further simplification, that means by cross multiplying. Look at here, minus U plus R over minus R plus V equal U over V. By cross multiplying, V into minus U plus R equal U into minus R plus V. Then opening minus UV minus VR equal minus UR plus UV. Then minus UV plus VR, here plus VR. Now collecting this UV here, collecting one side, that is minus UV, collect this one is minus 2 UV, minus 2 UV plus VR equal UV. UR equal to minus UR. Further, UR plus VR. Look at here. Come UR, come this side is UR plus VR, which is equal minus 2UV goes plus 2UV. Then dividing throughout U VR. The factor U VR, we get UR divided by UVR equals to 1 by V plus VR divided by UVR is 1 by U equal to UV, that is 2 over R. Therefore, this is the mirror equation. This equation holds true even when a virtual image is formed by concave mirror. Hence, the mirror equation of spherical mirror is 1 by U plus 1 by V equal 1 by F. So, further, this is equal 2 by R equal to 1 over F. This is for concave spherical mirror is 1 over F equal to 1 over U, 1 over V plus 1 over V equal to 2 over R. Then same for convex lens is, look at here, 1 over F equal 1 over E minus 1 over U. This is the difference. So far we discussed about what is mirror equation and its derivation clearly. We have done. Please subscribe our YouTube channel. Further, the magnification in image formation. When a concave mirror is placed very close to the object, it forms a magnified, erect and virtual image. The image appears larger than the actual object and is upright. The virtual image is formed as the reflected rays appear to diverge from the point behind the mirror. This is the important point. Note it. Have done. Please subscribe our YouTube channel.